Hello YouTube, this is Umozo3. In the previous video, we studied something called threading, and we said that basically Java is a multi-threaded programming language, which means that it can basically execute multiple tasks concurrently, okay? And it can prioritize tasks and prefer higher priority tasks. And so it can basically chunk out sections of its memory to execute multiple tasks at the same time. And so what we did in the previous video is we looked at two approaches to threading. And we said if we want to run multiple components of a computer program concurrently, there are two options for doing that. And so basically what you need to do is either you can, in the first approach, what we talked about is we said, well, we need to create a class that's a subclass of thread. And we said, what is thread? Well, thread is an important class in Java. So thread is already defined. And it has an API in here. And so if you were curious enough, one of the things that we did in the previous videos, we looked at the Java API for the thread class. And so then if you go ahead and look at that one, what you would essentially be looking at here is you would see that there's a thread class, okay? And there's lots of functions defined, right? Like start, stop, run, join, is alive, sleep, things like that, right? And so what we did is we created a subclass of thread. And we just give it one little instance method. You don't have to worry about constructors or getter methods or a toString method or anything like that. There's one method in this subclass, and it's called a run, okay? And so what you would do is you would say system.out.println of subs, okay? So that would just be an example of a program instruction. And so that's these first two steps, right? You extended the thread class, you define run method, and there's just two other things that you have to do. So now you would create an instance of that subclass and then call the start method on it. It's really not too difficult, right? And so now if you go into the try me class, this was sort of a tester class that we wrote. And so what you would do here, I guess this was the example of the second approach. So we're going to talk about this in a second. But what you would do is you would basically say thread me a equals new thread me, okay, or something like that. And then you could basically say a.start, okay? And so you would be creating an instance of the subclass that we made. And then you can just go ahead and call the start function. So now if we go ahead and run the main method, you get the sup there. So hopefully that's clear to you. But we almost ran out of time in the previous video to talk about the other approach to this. So if you don't want to create a subclass of thread, define the run method, create an instance of the subclass, and then call the start method on it, there's another approach. And I actually think it's slightly more difficult. But the other thing that you could do is implement Runnable. So you need to implement an interface. And then you're going to define a run method in that class that implements the runnable interface. So I'm going to show you what I mean by that. We created a class called loadMe. So we say public class loadMe implements runnable. Okay, and so runnable is an interface. Runnable is already an interface. It's already defined in Java, and it literally has one specification. So it says, okay, any class that implements this interface needs to specify a run function, and that's exactly what we do. Like if this hadn't been here, then we would have a compile time error because we cannot implement an interface without providing concrete definitions for all of the abstract methods in the interface. And so here we do provide a concrete definition of run, and we just say system.out.println of hockey stick after implementing the runnable interface. Okay, and so now what you would do is you would go back into our sort of tester class, you'd go back into try me. Okay, and so what you would do here is you would say load me y equals new load me. So you need to create an instance of the class that implemented the runnable interface. Okay, and then you need to create an instance of the thread class. So now you say thread z equals new thread of y. So you need to parameterize, you need to pass in the instance of the class that implemented the runnable interface, right? And so then you create a thread instance, and then you would just say z.start. Okay, so these are two different approaches. And you can see probably one is slightly more difficult than the other, but now you can go ahead and compile this and you would get the same result, well, not the same result, but it would do the same thing. So you would get hockey stick printed on the console because that's what the run function was instructed to do in the class that implemented the runnable interface. So hopefully that's clear to you. What I wanted to talk about in this video is called linked lists, okay? And we've already talked about a couple of data structures in Java, and in the videos to come, we're going to be talking about some more advanced data structures. But in this video, I wanted to talk about basically, we've already talked about arrays and array lists, okay? And we're going to be learning about a new type of list in this video. We're going to be talking about something called a linked list, okay? And there are different ways to hold multiple elements. There's different types of collections of elements, okay? So we already know that an array is not the same thing as an array list, right? An array has sort of simpler syntax, but an array list provides a lot more functionality, okay? Arrays can hold primitives, right? But array lists are better probably for holding objects and things like that. So anyway, what we can do is we can try to go ahead and look at this egg class. So I created a very simple sample class. Okay, and so I have a sample class here called egg, okay, and it's going to implement the comparable interface. In a previous video, we said that if we implement the comparable interface, we need to have a method called compare to. It's an int method called compare to, and it accepts an object. And if you don't believe me on that, what we could go do is go take a look at the comparable interface. So I'm being a man against my word right here, and using Google instead of Blackhole. But what you would do is you would do comparable Java API, right? And you could look at the interface, right? And there's one function that needs to be specified here, and it's called compare to, right? And it returns an int. And so then if we're going to implement comparable, then we need to specify the behavior of compare to. So how are we going to compare one egg instance to another egg instance? How would we say that one egg is quote unquote bigger than another egg, and what would that mean? But anyway, we just declared two private instance variables here at the top. So we have A and B. And then we have two constructors. So one of them will accept both parameters, egg of int A and int B, and then it would just assign them, right? So it uses the this keyword. We said that the this keyword prevents ambiguity between the name of the instance variable and the name of the parameter that's being passed in. So the A on the left refers to the instance variable. The A on the right refers to the parameter A that was passed in sort of as a dummy variable. But anyway, these are two constructors, and so we'll either assign A and B to A and B, or we'll assign them to 0 if nothing is passed in, right? And then we can also pump A or pump B, and so that would just be adding 1 to either of those instance variables. These are just void methods, kind of like setter methods, but they don't take in any parameters. We're not really setting something so much as just doing a simple modification, a simple increment, right? So this dot A plus equals 1, it would increment the value of the A instance variable for that particular instance. Same thing with the pump B method. And then resolve. So what does the resolve method do? Well, it returns an int. So you could say system.out.println of p.resolve, right? If p was some instance of the egg class. And then what it would do is it would return a minus b. So it would just return this instance variable, the value of that instance variable, minus the value of the second instance variable, right? And then the last function that we have to look at is the compare to method. So what we need to do, remember, we pass in an arbitrary object, but then we need to convert it to the type that we're interested in, right? So here, this is the egg class. So let's convert that object that we're trying to compare to, of course, to an egg, right? You would compare an egg to an egg. So you'd say egg y equals egg of z. So it'd be like the egg, it'd be an explicit cast from an object into a more specific egg, right? It's like the polymorphism stuff that we're talking about. And then you would say if resolve is greater than y.resolve, right? So if for the instance that I'm talking about, this is an instance method. You call it on an instance. So for my instance, right, for myself, if the result of my resolve, if my A minus my B is greater than his A minus his B, right, is greater than the object that we're comparing to, then we'll return 1. We would say that my egg is bigger than the other person's egg, right? We would return 1. But then if it was, if my A minus B was less than their A minus B, then we would return -1. Okay, if they were the same, if my A minus B was 7 and their A minus B was also 7, then we would return 0. We would say that those egg instances it could be considered equal. So hopefully that makes sense to you. But this is a simple class, and you really need to be familiar with these types of instance methods and how these come together, because we've already spent probably more than half of the curriculum exploring object-oriented concepts. But anyway, what we need to do is now we're going to have an egg tester. So now we've already created egg objects, and I want to talk about a linked list, okay? So basically, there are different types of data structures in Java. So we already know that arrays have fixed length. They cannot add or remove elements, okay? They can hold primitives. So they can hold, basically, we talked about primitives, right? And so the primitives are int, double, char, boolean, so those are basically the 4 primitives that you're talking about, right? And there's other ones, okay, if you're interested enough, there's actually other types of ints. There's like a long int that you could have, so it would be just lowercase long is technically another type of primitive, but you don't have to worry about that, just focus on those 4. And then you say array of k would get the element at index position k, right? So that's basically what we know about arrays. Okay, and array lists, though, array lists are different, right? Because once we started talking about object-oriented programming, we said it would be nice to have a flexible data structure where we can add or remove elements and not, adhere to some fixed constant length. And so we would create an array list that starts at a length of 0. It first has 0 elements in it. but then we're just going to add elements from there, right? And we said it can only hold objects, and that's why we talked about wrapper classes first. So that's why we talked about the integer class and the double class with a capital D, the character class with a capital C, and the Boolean class with a capital B. I think that was lesson 25 or 26. And I can provide a link to that video in the description if these wrapper classes are unclear to you. But the point is that you can't pass in an int to an array list. You have to pass in an integer. You have to pass in an object, okay? And you would say ArrayList.get of k gets the element at index position k, right? So this would be an instance method. You call it on a particular array list, and you have to pass in an int. So you pass in an integer, and it would return the element that occupies, that index position. What's the element at that index position? There's another type of list in Java. So there's there's an array list, which you're already familiar with, but there's also a linked list, okay? So a linked list is both similar to and not similar to an array list. It's similar to an array list because a linked list can also hold multiple objects. It can also add or remove elements, and it can retrieve values at index positions, okay? And that's some of the functionality that we've already been familiar with from the array list class. What's the difference? So the difference is that linked lists are different because linked lists, there's a trade-off here. So when we talk about different data structures, basically we have to look at the strengths and weaknesses of them. There are some nice things about arrays. There are some not great things about arrays. There are some nice things about array lists. There's some not great things about array lists. And the same thing happens for linked lists. There's actually a trade-off to make. It turns out that linked lists are actually better than array lists at inserting and deleting elements, okay? And so when you get into further computer programming courses, if you go into the second and third or fourth semester, or whatever you're working on, or if you're just learning this for fun, but after the introductory course, you start talking about time complexity and space complexity. And we can't just write whatever programs we want. We have to think about how exhausting they are for the compiler and how much space and time they take up. But anyway, the point is that linked lists are going to use a lot less time in inserting and removing elements, okay? And so we could do a quick Wikipedia search if we wanted to, but there's all kinds of documentation online about this. So what you can do is you can do linked list Wikipedia, and there's a general article about it, okay? And this applies to other programming languages. It's not just a Java thing, it's a programming thing, right? And so a linked list is a linear collection of data elements whose order is not given by their physical placement in memory. This is the distinction to be made, because with array lists, we're talking about this relationship between we have an index position, then an element at that index position, right? At index position 2, we have an object. At index position 7, we have another object. But with linked lists, you can't really think of elements occupying index positions. What you have to think of is that every element in the linked list is going to link, it's going to point to the next element in the linked list. So it's a data structure consisting of a collection of nodes which together represent a sequence, right? So here in this linked list, we have several elements, right? We have this element 12, that's the first element in the linked list, but then it basically has a pointer. And so here 12 is going to point to 99, okay? And so 99 is basically another node, it's another element in the linked list, but associated with that 99 is not just the value 99, but there's also a pointer, there's also a connection to the third node, okay? The third node is 37. Not only is there 37 there, but there's also a connection to, I guess whatever the next node would be. But here it looks like the linked list is going to stop. So it says the last node is linked to a terminator used to signify the end of the list. So you don't have to worry too much about that. But the trade-off here, the principal benefit of a linked list over a conventional array is that the list elements can easily be inserted or removed without reallocation or reorganization of the entire structure. So what we can do, I want to go ahead and pull up some examples here and not be too conceptual. We want to move into some programming and understand how this works. So we already have an array list example. We've already talked about array lists, right? And you can create some egg instances, so new egg of 5 and 2, right? So those will be the values of A and B for that particular instance. And then you can go ahead and add elements to the array list, right? But if you wanted to add an element to the array list at index position 0, this would actually be a lot of work. Because once E1 and E2 go into the array list, then if you want to insert E3 into the array list at index position 0, not only do you have to do that step, but you also have to scoot over the index positions of the other elements. So if there were 82 elements in your array list and you wanted to add a new element to the very beginning of it, you would be modifying the index positions of all the other 82 elements, right? They would all add 1 to their index positions. And for an array list, that's a hell of a lot of work, actually. It's actually not easy to insert or remove elements from an array list. It's called an exhausting process. It takes a long time, actually. It takes multiple steps to update the index positions within an array list if you're trying to insert or remove an element at a particular place. The solution is to use a linked list, okay? And so what we're going to do is we need to take a look at the linked list documentation. So what you would do is you would go to blackhole.com, okay, and you could do linked list Java API, and we can take a look at some of the functionality that we have available to us here, okay? And so what we would do is we would click on the first link here if you're using Blackhole. Okay, and so linked list basically it provides a lot of the methods, okay? And the syntax is going to be very familiar and similar to an array list, but you have to understand that a linked list is going to be a lot faster when it comes to inserting and removing elements, right? But you're going to recognize a lot of these methods look familiar. Remember, we're not talking about an array list, we're talking about a linked list now. But it looks very familiar, right? The constructor is pretty similar, right? It doesn't really take any arguments. But you know, you still have add methods. So you have add methods to add elements to a linked list. You have a method to clear. Remember, we talked about how you can clear all the elements from an array list. Same thing with a linked list. You could clear a linked list, right? You can also see if an element exists within a linked list. You could say dot, list dot contains of, and then some object and see if it exists in there. You could say list dot get of, some index position. And then, so a lot of these methods are already familiar for you, but again, that we're not talking about an array list, we're talking about a linked list. It's a different type of list. And the trade-off is that it's going to be a lot faster at inserting and removing elements, right? And so then you can it's going to be the same type of functionality. It's going to be the same type of syntax. You would say linked list, of type egg, right? And then you can call the linked list something. So you could say my eggs. I guess I already wrote this line. So let me just uncomment this line here. But you'd say linked list of type, and then it has to be an object type, right? Just like with the array list, you can't pass in an int or a char. You would pass in an integer or a character. It has to be an object. So linked list of type egg, we'll call it my eggs equals new linked list of type egg, right? And then it's going to be the same type of functions that you can. So we're not going to. So then you can still do add, right? So you can add an element to the end of the linked list. You can also add an element at a particular index position within the linked list, right? You can also get an element that you can retrieve an element at a particular index position within the linked list. Okay, and then you can also, there's other things that you can do here. So you can say remove, right? And so you can say dot remove of, and then a particular index position. So you say list dot remove of 2, it would remove the element from the linked list at index position 2. So hopefully that's clear to you. And then also size, right? So we also said, okay, well, array lists have a size. You could say list.size, and that'll give you the number of elements in the array list. Same thing happens with linked lists. You could say, linked list.size, and that will give you the number of elements currently in the linked list, right? And then you can just go ahead and add things. So you could say my eggs.add of E1, right? And then you could say my eggs.add of E2, right? And then you can just go ahead and add these elements in to whatever index positions you want. So we could just go ahead and sort of stack these things onto the end of the linked list. But then what we could do is we could go ahead and add E4 to index position 0. Okay, so we're going to get these 3 egg objects, right? You're going to get E1, E2, and E3, but then we're going to put E4 in front of all of them. So it's going to be E4 and then E1 and then E2 and then E3, right? And then it's going to be the same kind of syntax. It's going to be the same kind of notation that you have here. So basically what we can do is we can remove the references to the array list, and we can just think about the linked list now. Okay, so we have egg objects here, right? And then you can delete this basket because now we're talking about a linked list, right? And then you can still iterate through it. You can still use a for loop or a while loop or a do while loop to iterate through it, right? And so you could basically say, you'd have to be careful about this, but you could basically say do, and then you could say, system.out.println. What if you wanted to say basically, you could say my eggs.get of s dot resolve. Okay, and so that would call the resolve instance method on that particular egg object, right? And then you'd have to remember to increment s. So you'd be iterating through the linked list. You'd be iterating through the linked list, and you'd be printing the result of resolve each time. Okay, and then we'd also have to, of course, have while s is less than, and then it would be my eggs.size. Okay, so this is showing you a couple of the methods of the linked list class, right? We talked about the add method, we've already talked about the get method and the size method. And so this is just demonstrating some of the functionality to you, right? So now if we go ahead and compile it and then we go ahead and run it, then we would see the result of the resolve method. So it would print the a minus b for those 4 egg objects. So this was the result of a minus b for E4, This was for E1, this was for E2, and this was for E3. But you have to remember that linked lists are a lot better than array lists at inserting and removing elements. It's a much more efficient process with a linked list because it has a different structure. So hopefully that was interesting for you, and we'll talk more about it in the next video. From UMozo3, thanks for watching, and please subscribe.